kinematics. Let us deal with the first problem. So in this segment we are dealing mainly with the motion in two dimensions, that is motion in a plane. So the first one, the radius vector of a point A relative to the origin varies with time t as the position vector is given to us as at I cap minus bt square j cap, where a and b are positive constants and I and j are unit vector of the x and y axis. Find the equation of point's trajectory and we have to plot this function. So if I begin with the first problem, so I can say that x is equal to at and y is equal to minus bt square. So from here I can write that t equals x by a, and if we put t equals x by a in this equation, we obtain minus bx square upon a square. So the equation of a trajectory which is independent of time is equal to minus bx square by a square. So if I plot this with respect to x and y axis, so we can consider it in this way, that if this is x axis and this is y axis, then it will be a parabola something like this, because the value is minus b by a x square. So the next question is asking the time dependence of the velocity v and acceleration w vectors as well as of the moduli of these quantities. So if we look at this aspect, so we are saying that the position vector of the particle r vector is equal to at I cap minus bt square j cap. So if we write velocity vector, then velocity vector can be written as dr by dt, and if we differentiate this equation with respect to time, we obtain a I cap minus 2 bt j cap. And on redifferentiating this, we obtain the equation for acceleration, that is, it can be written as dv by dt, and if I differentiate this, then I will be left with minus 2v j cap. So the next part which the question is asking is to calculate their mod values, that is their magnitude. So the magnitude of velocity can be written as a square plus 4b square t square square root, and that of acceleration can be written as minus 2b, or we can simply write it as 2b because we are only writing the magnitude. So now let us deal with the third part. The third part is asking the time dependence of the angle between the velocity and acceleration vector. So if we calculate the angle between them, so we are using the concept of dot product. So I can write that cos alpha is equal to v dot acceleration upon magnitude v magnitude of acceleration. So if we perform dot product between these two vectors which we have obtained, so we can say that only j cap will get multiplied and we will obtain 4b square t upon magnitude of v, that is a square plus 4b square t square, and the magnitude of this, which is equal to 2b. So we obtain something equal to 2bt upon root over a square plus 4b square t square, and from here I can write that alpha is equal to cos inverse of this quantity, that is 2bt upon root over a square plus 4b square t square. So this is the angle alpha which we were talking about. The next question that is asked is the mean velocity vector averaged over the first t seconds of motion and the modulus of this vector. So the last part is asking us to calculate the average value of velocity. So the average value of velocity is written as integration of v dt upon integration dt. So if we write this quantity over here with respect to this velocity vector which we have obtained, so I write it as a I cap minus 2bt j cap dot dt, this is under integration upon integration dt, and we are taking time from 0 to t. So the denominator will become equal to t from between 0 to t, and on solving we obtain it as a I cap minus b t j cap. Now the next portion is to calculate the magnitude of this average velocity. So the magnitude of this average velocity is a square plus b square t square the square root. So this is the answer to the last part which we obtained. So with this we have solved the first one.